But let's see. And then to convert from radians to degrees, we multiply by 180 over pi. So if I give you 3 radians, and I want you to convert that to degrees, we're going to multiply by, I want my radians on bottom. 1 radian is equal to how many degrees? 180 degrees. Right? Gotta do that. Pi radians. What are we doing? 180 is not. Yeah, 180 over pi. That's what I was looking at. That I was like, 180 is not equal to 1 radian. So therefore, 180 over pi. So radians cross cancel, and it leaves you with degrees. That's the reason we put radians on top and bottom. So 3 times 180, 540 over pi, which you would type into your calculator. Bring it up. Second quit. So 540 divided by your pi's right above your caret symbol. 171.88. We'll call it 172 degrees. And think about that. Would that be right? What's 3.14 radians? That's pi radians, right? How many degrees is that? 180. Yeah, 540 degrees. Oh, I should have put the degree symbol there. If 3.14 is 180 degrees, does it make sense that 3 would be a little bit less than that? Which is 172 degrees. So that makes sense. That's legal. But the easy way, guys, let me show you. You'll have some examples. Let me scroll down and work examples. Example 2 and 3. We're changing back and forth. Example 2 says change the following degree measures to radian measures. First one, 30 degrees. Let me go ahead and write these down. 30, 210, and 360. 30 degrees, 210 degrees, 360 degrees. 2 of these should be very easy to do in your head. 30, did we do that a while ago? Think about, again, if pi is 180, take 180 and divide it by something, give me 30. 6, right? 180 divided by 6 is 30, so 30 is going to be pi over 6. 180 divided by 6. But if you don't want to do that, here's how you change it. 30 degrees over 1 times 180 degrees goes on bottom, pi radians goes on top. Degrees cancel. 30 and 180 cross cancel and leaves you with 1 and 6. Pi over 6 radians. Any questions? 210 degrees. Let me show you. Yeah, well, the reason for that, if you have degrees on top here, you want degrees on bottom here, so to cross cancel. Here's another shortcut. 30 is pi over 6. 30 times what gives you 210? 7. So does it make sense that 7 of these is equal to 1 of these? So it's 7 pi over 6. If 30 is pi over 6, then this is 7 of them, so this should be 7 pi over 6. Makes sense because 7 times 30 is 210. So, but let's do it the long way. 210 degrees times pi over pi radians over 180 degrees. Degrees cancel. 210 and 180, what divides into both of those? 30 gives you a 7 and a 6. On top you have a 7 pi. On bottom you have a 6. 7 pi over 6 radians. Any questions? 360 degrees, what's that going to be? 2 pi. 360 degrees over 1 times pi radians over 180 degrees. Degrees cancel. 180 and 360 cancel and leave you with 1 and 2. That is 2 pi radians. And I'm just abbreviating radians there. If nothing's written out there, if you just say 2 pi, the angle is 2 pi, then it's understood to be radians because there's no degree mark. The next part says change from radians to degrees. Pi over 2, 3 pi over 4, and 4.6. Pi over 2, here's the hard way of doing it. That's pi over 2 radians times, let's see, what did I tell you to multiply by to change it to 180 over pi. Pi's cancel. 180 over 2, which will cross cancel also, but it's going to give you what? 90 degrees. That's the hard way of doing it. And that's not even hard. Here's an easier way. How many degrees is that? 180. So why not just take out pi and put in 180 and divide it by 2? That's it. If it has a pi, except for the third one. You can't do it for the third one. That's the reason I show you both ways. So put 180 degrees there, because that's pi. 180 divided by 2, that's 90 degrees. On the second one, I'm just going to do it with a shortcut. Instead of 3 pi over 4, I'm going to do 3 times 180 degrees over 4. 180 over 4 times 3. If you multiply that out and divide, you should get 45. No, you don't. Let's try that again. 135 degrees. 3 pi over 4 is 135. The way that I do that, I know what pi over 4 is. I know pi over 3, I know pi over 4, and I know pi over 6. Pi over 3 is 60. Pi over 4 is 45. Pi over 3 is 60. Is that what I said? Pi over 6 is 30. No, I know those three. So if pi over 4 is 45, then this is 3 of those. 3 45s is 145, 135. And the last one, 4.6, you cannot use a shortcut on this. That's the reason I show you the long way as well. Before I start, though, can you tell me what quadrant that'll be in? This is 3.14. This was 4. What was it? .71. So it's going to be third quadrant, right? To convert it, 4.6 radians over 1 times 180 degrees is pi radians. Radians cancel, so you're going to do 4.6 times 180 divided by 3.14. 263.56. We'll call it 264 degrees. Which again, it was nearly fourth quadrant, because that barrier line was like 4.7 something. So that's the reason it's so close. That's actually 270 degrees there. So that's the reason it was that close to 270 degrees. So that's right. 264 degrees. We multiplied 4.6 times 180 and then divide your answer by pi. We went ahead and divided it. Yep. Here we go. Note, increasing an angle by 360 degrees resulted in coterminal angles. Increasing an angle by 2 pi radians does the same thing. That's just a note. If something's in radians and you want to find the coterminal, you just add 2 pi instead of 360. Arc length. Obviously, we need to go back and review some of our 8th grade math real quick, because we don't know what circumference is. So, it says the distance all the way around a circle is called circumference. An arc length is a fractional part of the circumference. It's the length of an arc. Like if you're walking a circular path, okay, you've got a walking trail or something. If you're walking that circular path, that's circumference. What if you only walk part of it? The distance from there to there. That's the length of an arc. That's called an arc. So obviously the distance from there to there would be the arc length. That's where that comes from. The way that you need to think of that, arc length is a fractional part of the entire circumference. Keep in mind there's 360 degrees in a circle. That's going to be an important factor in a second. So circumference all the way around, arc length part of the way around. A central angle, let's talk about, this is just definitions real quick. A central angle would be an angle whose vertex is the center of the circle. So let's say this central angle, about how many degrees would be in that central angle? It's close to 90. I'd say about 87 probably, a little bit less than 90. That's what a central angle is. Okay, so before we move any further, can you tell me what fractional part this angle is of the entire circle? If it was 90, it would be, but it's not exactly 90. It's 87 over 360. That's what part it is. There's 360 total degrees. This is 87 of them. So the fractional part this is of the entire thing is 87 3/60ths. So about 2.242. let's see. It says we can find out what fraction an arc is of the whole circle by looking at the intercepting central angle. There's 360 degrees in a circle. Example 4. Let's work some of these. It says, example 4, the second hand on a clock is 5 inches long. How far does the tip of the second hand travel in 50 seconds? Notice 50 seconds is not going all the way around, correct? How long does it take for the hand to go all the way around the clock? Thank you. Everybody understand that? So in 50 seconds, what part of how far around does it go? What fractional part? 50 60ths, it travels 5/6 of the way around. In 50 seconds, that second hand goes 5/6 of the way around the circle. Does that part make sense? So, we don't know how far it travels in that 50 seconds. So, instead of going from here all the way around, it's going maybe from here around to about here. So, we're not traveling the entire 360 degrees. So, these problems, you pull your common sense out of the closet for a second. Okay, the entire circle, I said that was the circumference. Well, how do you find the circumference of a circle? Does anybody know? Pi times diameter, pi d, or 2 power. So therefore, let's find, before we do anything else, let's find the entire circumference. If it did go all the way around the clock, how far would it go? Let's say it's 5 inches long. So the radius of your clock is 5 inches. So what's the diameter? 10. So the circumference is going to equal 3.14 times 10, which is 31.4 inches. Any questions on that? So that's the distance all the way around. Did your second hand go all the way around? It went 5/6 of the way. So all you have to do to find out how far it went is you take 5/6 of 31.4. Any questions? How do you take 5/6 of 31.4? What does of mean? 5/6 times 31.4. If you want to do it over 1, that's fine. 5 times 31.4 divided by 6. Anybody got that? Say again. 26 point, we'll call it 2 inches. Again, I'm going to review what the steps I just went through. How far it traveled in 50 seconds. Here's all the things I just did. Step 1, find the circumference. The circumference is the distance all the way around the circle. The distance all the way around this circle was 31.4 inches. And then find out, okay, it didn't go all the way around. It only went a fractional part around. In 50 seconds, okay, it traveled 5/6 of the way around. So instead of going to the whole 31.4 inches, it only went 5/6 of that way. 5/6 of that distance. So next, in the very last step, find 5/6 of the 31.4, which is 26.2. So it traveled 26.2 inches instead of, and I could say how far would it have to travel to make it the rest of the way, and you could just subtract those two numbers. Does that make sense? You can handle that? Well, yeah, it does, doesn't it? I'm kind of backwards there. My bad.